So we're going to move on to page 4 and the types of problems you're going to see on page 4. Page 3, it was applying properties of exponents. Therefore, everything had the exact same base and you had different exponents. The next page is the exact opposite of that. We're going to apply properties with the same exponent. The bases are going to be different. So we're going to need to see what we're going to have to do when the bases are different. So if the bases are different, but the exponents are the same, you can simply multiply or divide the bases together and keep the exponent. Both the properties from page 3 and the properties on page 4 are kind of shortcuts. You want to have a situation where you can use the first properties where the bases are the same, or you can use these properties where the exponents are the same. There are a lot of ACT questions that go over these type of properties. So here's a very simple example. Notice I have different bases. My bases on this one are 3 and 4, but my exponents are the same. So once I can see that my exponents are the same, then I can use this property right up here. Then I can multiply my bases together. So that's what I'm going to do. I'm going to multiply my bases together. 3 times 4 is 12. And then I simply keep my exponent. Just that easy. So, if they want it as a single power, then you would leave it like this. If they said evaluate it, then I would have to take 12 to the second power. 12 times 12, 144. You need to read the directions and see which way they want you to keep it, whether they want you to keep it as a single power or if they want you to evaluate it. So let's look at one where you're dividing. So on this one, my bases are different, exponents are the same though. So I'm going to use this property that, hey, if the bases are different, but my exponents are the same, then what I'm going to do is rewrite it like this, to where everything has the exact same exponent. Luckily on this one, I can actually divide these in here. 4 divided by 2 is 2, and this is simply 2 to the second power. And 2 to the second power is 4. If they wanted it as a single power, then I would leave it like this, probably without the parentheses. If they wanted me to evaluate it, I would leave it like this right here. Now these where you can divide seem to be simple, but the ones where you can't divide seem to give students a lot more problems, because you can't divide these. They're expecting you to be able to divide these numbers, and you can't always divide the numbers. So what you're simply going to do is rewrite it with parentheses, put 5 divided by 3. I'm going to divide my bases, put my exponent on the outside, and then that's it. I'm going to leave it just like that because I can't divide 5 by 3 and get a whole number. I could get a decimal. If they want decimals, again, look at your directions, see what they want. If they would evaluate it, then I would have to divide these. So I'm going to go over examples that are like the ones on page 4. So let's look at these first ones. Pretty straightforward on these. I'll look at my bases. They're different, but look at my exponents. They're the same. As soon as I see that my exponents are the same, I can multiply these bases together. And I'm going to do that. 8 times 11, 88. And I keep my exponent. Look at the next one. Both of these really have the exact same exponent. That means I can simply multiply what's inside the parentheses. If you wanted to use your order of operations, that rule, it would work on this as well. So 10 times 5 is 50. And this is simply 50 to the third power. Look at ones where we're dividing. Okay. I have different bases, but the same exponent. My rule is if I have the exact same exponent, then I can divide these bases. So I'm going to try and do that. 4 divided by 5. 4 divided by 5 is not a whole number. So I'm going to leave it as a fraction, and I'm going to keep this exponent for that new number, which is a fraction, 4/5. I'm just taking 4/5 to the third power. And one more. Bases are different, exponents are the same. If the exponents are the same, I can actually divide these. So, like the other ones, 8 divided by 2, and I'm going to keep that same exponent. But unlike this one up here, I can actually divide these numbers. 8 divided by 2, 4. 4 to the fourth power. I can leave it with parentheses, or I could write it like this. If they wanted me to evaluate it, I would have to go 4 times 4 times 4 times 4. 2 more. Base on this one, -3. Base on this one, -8. But look at my exponents. They're the same. As soon as I have the same exponents, I can multiply these two together. So -3 times -8, a negative times a negative is a positive, +24. And then I keep my exponent since it's the same. So let's try this one. Okay. Inside here, I've got different bases, but the exact same exponent. So what I'm going to do is I'm going to rewrite it like I did the other ones. I'm going to use parentheses, 4 divided by 16. Put this exponent on the outside, but look, I'm going to have another exponent. That 2 out there on the outside. I can't divide these, but I can reduce this fraction. What number will go into 4 and 16? 4. I divide both of those by 4. 4 divided by 4 is 1. 16 divided by 4 is 4. And this is a situation like we were seeing on page 3, where it's a power of a power. And what can you do with these exponents when it's a power of a power? You can multiply them together and make one set of parentheses with one exponent on the outside. So I can leave my answer like this with parentheses, or I can do this. It's simply 1/4 raised to the 6th power. I could do this because the exponents were the same, the bases are different. I rewrite it, simplify it, and then use previous laws that we've gone over to multiply these together to get this. The next video is going to go over the last 3 problems. The last 3 problems are a little bit more advanced, but we can do them.